Hello GCC 107 students, welcome back to our ocean acidification chapter. This is the second recording. We're now going to talk about pH. The pH scale goes from 0 to 14. So 0 is the lowest number, 14 is the highest number. So it ranges from 0 to 14. 7 is therefore right in the middle. 7 is considered neutral. So a pH of 7 would be like pure water or something that's neither acidic nor basic. Pure water has a pH of 7.0. Now as you go from 7 down towards 0, you're getting more and more acidic. As you go from 7 up to 14, you're getting more and more basic. So the ocean is naturally a little basic, but it's been becoming more acidic over the last 30-40 years with the increase in CO2 in the atmosphere. This is just for fun. It shows some pH levels. Stomach acid, so hydrochloric acid is what's in our stomach, is about 1.5. Lemon juice is about 2.3. Sodas, like Coca-Cola, can be 2.7 to about 3.5. Tomato juice is a little above 4. I know coffee is around 5. Milk is around 6.5. Pure water, again, is 7.0. Blood is around 7.6. Seawater is around 8.1 now, but it's going down. It's getting more acidic. Milk of magnesia is an antacid medicine, and it's about 10.5. Ammonia, a cleaner, is about 11.5. And then oven cleaner, which is very dangerous, has a pH close to 14. That's one of the most dangerous things you can buy is oven cleaner. Notice also, normal rain is at a pH of 5.3. Acidic rain is considered anything less than that. So we're going to talk about acid rain in this chapter. Again, this is just for fun, some more pH values. Battery acid is really acidic. It's sulfuric acid, and it's at about 0.5, so just a little above 0. Orange and apple juice around 3.5. Beers around 4.5. Coffee, I mentioned, is around 5. Seawater is around 8. Bleach is around 12.5. And household sodium hydroxide lye is around 13.5. Again, that's getting pretty dangerous. Again, the closer to 0, the more dangerous the acid is. The closer to 14, the more dangerous the base is. So let's talk about some of these household items. Vomit. Vomit is from stomach acid or gastric acid. The pH is between 1 and 2. The acid in your stomach is HCl, hydrochloric acid. That's the acid I want you to know. HCl causes proteins to denature, and thus it digests our food. It also inhibits the growth of microorganisms in the stomach, which can prevent infection. Heartburn and acid reflux are caused by gastric acid regurgitating up the esophagus. It's not meant to be there, and so it burns. It hurts, so you have to take medicine for that. Acid is produced in the stomach as an aid to digestion. It is not intended to be present in the esophagus, as I mentioned. Citrus fruits, oranges, lemons, grapefruit, tangelos, tangerines, limes. All of those contain citric acid. It's responsible for the acidic or sour taste in the fruit. Lemons have an especially high concentration of citric acid. Citric acid is a natural preservative. It was isolated back in 1784 from lemons. It's used to flavor many soft drinks. Many soft drinks have citric acid in them. It can also be used as a cleaning agent. The pH can range from 2.0 to 3.5 for the citrus fruits. Citric acid looks like this. There's a molecular representation of it. So we see we have carbons in black, hydrogens in white, and oxygens. There's 7 of them, and they are red. That's the molecule right there. Vinegar is an acid. It's acetic acid. It's produced from the fermentation of ethanol, which is why bad wine, when it goes bad, it tastes vinegary. Used in foods dating as far back as the Egyptians in 3000 BC. There are many types of vinegar. There's malt vinegar, wine vinegar, balsamic vinegar, rice vinegar, palm vinegar, cane vinegar, and more. We use it in a lot of salad dressings. It can be a pickling agent. It can be a cleaning agent. It's an eco-friendly weed killer, window cleaner, urine cleaner for pets, brush polisher, and coffee stain remover. I know every once in a while I'll run some vinegar through my coffee maker and it cleans up the brown stains in the coffee pot and the coffee maker. After you've run the vinegar through, you do need to wash it with water and let water go through several times so that your coffee won't taste bad. So vinegar is another household acid. And you might want to remember it's in salad dressing. Vinegar, right? Here's a picture of vinegar, acetic acid. We see we have 2 carbons, 4 hydrogens, 2 oxygens. Oxygens are in red. That's the molecular structure right there. Vinegar. Sodas. Sodas are acids. They're a household item. The acids are added to the soft drinks to give them that tangy bite. We like the taste of acids. We eat lots of acidic foods and beverages. The pH of sodas can range from 2 to 4. Phosphoric acid is usually included in a soda. It's used as a buffer and a rust remover. It's cheap and produced in large amounts. Citric acid is often added to soda as well. We already discussed that. The carbonation process itself results in carbonic acid being in the soda. So we actually have 3 acids in soda. That's why it's so acidic. It's very important in the buffering of blood, the carbonic acid. And carbonation is when we just bubble CO2 and dissolve it in the liquid. So to get carbonation, we bubble CO2 into the water, keep it under pressure and pressurize it, keep that CO2 in the can or in the bottle for our sodas. So here is what phosphoric acid and carbonic acid look like. The top one is phosphoric acid with a phosphorus in the middle. We see 4 oxygens, 3 hydrogens. Carbonic acid has the carbon in the middle with 3 oxygens and 2 hydrogens. Citric acid we've already looked at. So again, those are more molecular models and representations of the molecules of some acids. Soda can erode the enamel off your teeth. Here's a list with several different kinds of soda. Again, they range from 2.3 up to about 4. So maybe you have a beverage you drink in that list. So you can look at it for a minute if you need to and find something you drink. So once we are below about pH 5, the enamel on your teeth starts to erode, and what's underneath is yellow dentin, and that's when your teeth get very, very sensitive when the enamel is wearing off. So drinking a lot of soda can cause sensitivity and yellow teeth. Here's some lovely pictures of acid erosion of teeth from a dental publication. It's really hard to tell the difference between meth mouth and acid erosion in your teeth. So you can see in that middle picture, looks like the teeth were kind of breaking off. They got so thin. That's actually very similar to what happened to my mouth because I drank so much soda in my 20s and 30s that my teeth had the enamel wear away, they turned yellow, and they were chipping off. It was very painful. I had very, very sensitive teeth. So I went to several prosthodontists who specialize in this, and they all said the same thing. We can put dentures in your mouth for $5,000, pulling all your teeth, Or we can crown all your teeth for $30,000. So I crowned all my teeth for $30,000. So my mouth costs more than your car, most likely. Yes, I crowned all my teeth and stopped the sensitivity, stopped the breaking, all because I drank soda. Thank you. So be careful what you drink. You don't want to be like me and put all your money in your mouth. Tap water. Tap water is usually a little acidic and not neutral. That's because CO2 from the air dissolves in water. And here's the reaction again, the same one that's going on in our ocean. CO2 plus H2O makes H2CO3, carbonic acid, is produced, which again lowers the pH of water just like it's doing in the ocean. It's lowering the pH of the ocean water. You need to remember that reaction. CO2 plus H2O makes H2CO3, carbonic acid. It's making the ocean more acidic. It makes our tap water acidic. Soap. Soap is a household item. It's a base. It's usually made by reacting some sort of fat like an olive or a vegetable oil with lye, sodium hydroxide. pH tends to be 9 to 10. Lye refers to the base NaOH, also called caustic soda. And then we have KOH, which is caustic potash. Both are very dangerous. You can see the arm there was burned with some lye, sodium hydroxide. If you don't wash it off your skin, it'll cause chemical burns just as bad as fire burns. So very dangerous again. Bases are just as dangerous as acids. Pure lye needs to be stored in airtight plastic containers, not glass. It'll actually etch and eat away glass. Sodium hydroxide and potassium hydroxide are corrosive and will damage skin tissue like that picture, and it could cause eye damage. So soap is a household base. Ammonia is a household base. The formula is NH3. There's a picture of the molecule. The pH is about 11.5. It has a shape. We talked about shapes. The shape is trigonal pyramid. It's used as a cleaning product, and we also make fertilizers and drugs out of it. Household ammonia is actually mixed with water when you buy it. If you mix your ammonia with bleach when you're cleaning something, it makes a toxic gas. Bad idea. Never mix chemicals in your toilet bowl. You can produce a gas that will explode your pipes. You can explode your toilet. Do not mix cleaning agents. Again, ammonia and bleach makes a toxic gas. If you inhale it, you could become very sick. Ammonia is also very toxic to aquatic animals, so it's really not something we want to be flushing down the drain. NH3 was the first polyatomic molecule detected in space back in 1968. Drain cleaners, basic ones, they're mostly bases. Liquid drain cleaners contain sodium hypochlorite, bleach, and sodium hydroxide or potassium hydroxide in concentrations up to 50%. Wow, that's actually really dangerous. Drain cleaners are among the most hazardous household products available to the public. Keep away from children and pets. They can cause serious burns. So be careful, don't let it get in your eye. And that ends our household items. So we're going to stop there and we'll come back and talk more about acid rain. See you in a minute. Bye, GCC.